Hello friends, today let us solve some multiple choice questions based on the topic quadratic equations from class 10th maths part 1. So the question is, choose the correct answers from the following questions. The first one is, which one is the quadratic equation? Four equations are given below and from that we have to choose the quadratic equation. Now to choose a quadratic equation we must have the general form of a quadratic equation. So we know that ax square plus bx plus c is equal to 0. So this is the general form of a quadratic equation, which is the quadratic equation in variable x where a, b and c are any real numbers. One condition must be supplied here, that the highest degree of the variable it contains must be 2. Then only it can be a quadratic equation. Now we have to check out of these four equations given, which is the quadratic equation. So let us consider first equation, that is 5 divided by x minus 3 is equal to x square. If we consider this equation, as we can see right now, the highest degree of the variable x is 2, but on the left hand side we have the fraction, that is 5 divided by x. So first of all we should have this equation in the standard form and then only we can compare. So to write this in the general form of a quadratic equation, we must cross multiply here so as to have 5 into 1, that's 5, minus 3 into x, that's 3x, divided by x is equal to x square. Now if we take x to the right hand side, it will be 5 minus 3x is equal to x cube. And now if we can see, the highest degree of the variable x is 3 now, that's why this is not a quadratic equation. So the first equation is not a quadratic equation. Let us consider the second one, x into x plus 5 is equal to 2. Again we have to solve this, x into x plus 5, that is equal to 2. So this is the equation given. Now if we solve this equation, that is if we multiply by x inside the bracket, we will have x into x, that's x square, plus x into 5, that's 5x is equal to 2. That is we get x square plus 5x plus 2, coming to the left hand side it will become minus 2 is equal to 0. Now this is in the form ax square plus bx plus c is equal to 0, and the highest degree of the variable x is also 2. So this is a quadratic equation. So here the alternative B is a quadratic equation, that is x into x plus 5 is equal to 2 is the quadratic equation. So we need not to check the C and D option whether it is a quadratic equation or not, because we have got our answer, that is x into x plus 5 is equal to 2 is a quadratic equation. Let us have the next question. Out of the following equations, which one is not a quadratic equation? In these four equations, the three equations are a quadratic equation. We have to decide which one is not a quadratic equation. So if you consider the first one, that is x square plus 4x is equal to 11 plus x square. Now if we can see here, on both the sides x square is there. So if we cancel x square each other, we get the equation 4x is equal to 11, which is not a quadratic equation because this is a linear equation in variable x. That's why the first equation, that is option A, is not a quadratic equation as it is a linear equation. So we have got our answer, that is the alternative A is not a quadratic equation. Still we'll check the rest of the equations whether they are quadratic equations or not. So for option B, the highest degree is 2, x square is there, that's why this is a quadratic equation. For alternative C also, highest degree is 2 and variable is x, that's why this is also a quadratic equation. And in the option D also, if you take minus x square on the right hand side, it will be x square plus x square, that's 2x square. So that will be again a quadratic equation. So rest of the three equations are quadratic equations. Only the first equation is not a quadratic equation because it is a linear equation. So our answer is option A. Let's have the next question. The roots of the equation x square plus kx plus k is equal to 0 are real and equal, then find the value of k. So four options are given over here. Now to solve this equation, first of all we should write the equation that is x square plus kx plus k is equal to 0. Now here for this equation it is given that the roots are real and equal. Now if we compare this equation with the standard form of a quadratic equation, that is ax square plus bx plus c is equal to 0, then by comparing we have the value of a as 1, which is the coefficient of x square, value of b is k, and value of c is also k. Now it is given that the roots are real and equal. So if for any quadratic equation the roots are real and equal, in that case we know that the value of discriminant is 0. So to find the value of discriminant we should have b square minus 4ac, that is equal to, we have the values of a, b and c. We'll replace here b by k, that's k square, minus 4 into a is 1, into c, that is k. As the roots of this equation are real and equal, the value of discriminant must be 0, that is b square minus 4ac must be equal to 0. That's equals to k square minus 4 into 1 into k, that's 4k. So this can be written as 0 is equal to, if we take k common, we have in bracket k minus 4. So as the product of these two is equal to 0, that means either k is equal to 0 or k minus 4 is equal to 0. That is, either we get value of k as 0 or k is equal to, if we take minus 4 to the right hand side, it will become plus 4. So here two values we get, either 0 or 4. So amongst the four alternatives there is alternative C, which shows the values 0 or 4. That's why these are the values of k. So this is the correct alternative. Let's have the next question. For root 2x square minus 5x plus root 2 is equal to 0, find the value of discriminant. And the four options are given over here. Now to find the value of the discriminant, first of all we should write the given equation as it is, root 2 into x square minus 5x plus root 2, that is equal to 0. Now to find the value of discriminant we should compare this with the general form of a quadratic equation, that is ax square plus bx plus c is equal to 0. Now if we compare these two, we get value of a as root 2, value of b is minus 5 because we have to take the value of a, b and c along with the signs. That's why b is equal to minus 5, that is coefficient of x, and the constant term c is root 2, that is c is equal to root 2. Now as we have found the values of a, b and c, we can find now the value of the discriminant, which is b square minus 4ac is equal to, now b square, that is minus 5 square, we will replace here values of a, b and c, minus 4 into ac, a is root 2, into c is also root 2. So we should have minus 5 square, that's 25, minus 4 into root 2 into root 2, that's 2, that is equal to 25, minus 4 into 2, that is 8. So 25 minus 8, that's 17. So here the value of the discriminant is 17, which is given at option B. So option B is the correct alternative. Let's have the next question. Which of the following quadratic equations has root 3 and 5? So four equations are given over here. Now to solve this equation, here the roots are given. So suppose these roots are alpha and beta. That is, let alpha is equal to 3 and beta is equal to 5. Now if the roots of quadratic equation are given, suppose those roots are alpha and beta, then that quadratic equation can be expressed as x square minus alpha plus beta into x plus alpha beta is equal to 0. So to get the coefficient of x, we should add the two roots along with the negative sign, and to get the constant term we should multiply these roots. So by having the roots of quadratic equation, we can get the equation as x square minus alpha plus beta into x plus alpha beta that is equal to 0. Now if we compare these four equations which are given, the first equation is x square minus 15x plus 8 is equal to 0. Now if we compare here 8, which is not the product of 3 and 5. So these are the not roots of the first equation because the product of these two is not 8. Now consider the second one. The product of these two, that's 15, 3 into 5, that's 15, and the coefficient of x here is minus 8, which is the addition of these two roots, that is alpha plus beta, that's equals to 3 plus 5, that is equal to 8, along with the negative sign is there. So here the coefficient of x is the addition of the roots along with the negative sign, and the constant term is the product of these two roots. So both the conditions here are satisfied by these roots. That's why these are the roots of the second quadratic equation. Now if we compare the option D also, we have x square plus 8x minus 15, but only difference is there about the sign, because we want here the sign of the middle term as minus and the addition of these two roots. That's why we need here minus 8x, which is there in option B. That's why option B is the correct alternative. That is 3 and 5 are the roots of the second equation, x square minus 8x plus 15 is equal to 0. Next question is there. Out of the following equations, find the equation having the sum of roots minus 5. Now suppose for that one, if alpha and beta, these are the two roots given, then the quadratic equation we can get from these as x square minus into bracket alpha plus beta into x plus alpha beta is equal to 0. So this is the quadratic equation we can get if the roots are given. And here the addition of the roots, that is alpha plus beta, we have the formula for it as alpha plus beta is equal to minus b divided by a, and alpha beta is equal to c divided by a. Now here the question is asked that for which of these equations the sum of these roots is minus 5. So if we consider the first equation, now here we need the sum of the roots, that is alpha plus beta. So for this one, if we replace the values of b and a for each of these equations, we'll check it out for which equation we get the value minus 5. So for the first one, minus b is there, so minus, and the value of b is minus 15, so that should be in bracket, divided by a, that's 3. So here we get minus minus plus 15 divided by 3, and if we divide 15 by 3 we'll get 5, but we need here the value minus 5. So for the first equation the sum of the roots is not minus 5. Let's check it out for the second equation. For that equation also the value of b is minus 5, so minus into bracket minus 5 divided by value of a, that is the coefficient of x square, is 1. So again here we get minus minus plus 5 divided by 1, that's 5, but again we need the value of the addition of the roots minus 5. That's why for the second equation also the addition of the roots is not minus 5. Now let's check it out for the third equation. For the third equation the value of b is 3, so we should have minus b, that is minus 3, divided by value of a, that is coefficient of x square, is 1. So minus 3 by 1, that's minus 3, but we want here the value minus 5. So the third equation is also not our answer. Now let us check it for the last equation. For the last equation, alpha plus beta is equal to minus b divided by a. So instead of b we have 15 now, so we should have minus 15 divided by value of a, that is coefficient of x square, is 3. So if we divide minus 15 by 3 we get minus 5, and finally we get the value minus 5, that is the addition of alpha plus beta, that is the sum of roots, is minus 5, and this is for the fourth equation, 3x square plus 15x plus 3 is equal to 0. So for this equation, the sum of its roots is minus 5. Now let's have the next question. Root 5m square plus root 5m plus root 5 is equal to 0. Which of the following statements is true for the given equation? First is whether the roots are real and unequal roots, or real and equal roots, roots are not real, or it has 3 roots. So we have to choose the correct alternative. Now we can know the nature of the roots by having the value of the discriminant. So to find the value of the discriminant, first of all we should write the equation root 5m square minus root 5 into m plus root 5 is equal to 0. Now if we compare this equation with the standard form, ax square plus bx plus c is equal to 0, which is the general form of a quadratic equation, and if you compare, we get the value of a, that is root 5, value of b along with the negative sign, that's minus 5, which is the coefficient of the middle term, and the constant term c is root 5. Now by having these values a, b and c, we can have the value of discriminant b square minus 4ac. So b square, that's minus root 5 bracket square minus 4 into a, that is 4 into root 5 into c, that is root 5. Here we have minus root 5 bracket square. So as a square is there, minus sign will get cancelled, and root 5 square is there, that's why square of root 5 is just 5 minus 4 into root 5 into root 5, that's 5, which is equal to 5 minus 4 into 5, that's 20, and 5 minus 20, that's minus 15. So here we get the value of discriminant b square minus 4ac negative, that means it is less than 0, and we know that if the value of the discriminant is negative, the roots are not real. That's why for this question the correct alternative is alternative C, which is roots are not real. Let's have the next question. One of the roots of the equation x square plus mx minus 5 is equal to 0 is 2. Find the value of m. So to get the answer of this one, first of all we should write the given equation x square plus mx minus 5 is equal to 0, and for this equation it's given that one of the roots is 2. So if 2 is the root of this equation, we must put x is equal to 2, and as x is equal to 2 is the root of the given equation, that must satisfy the given equation. So instead of x we should write now 2, that is x square, that's 2 square plus m into x, that is 2 into m minus 5 is equal to 0. So 2 square is 4 plus 2m minus 5 is equal to 0. 4 minus 5, that's minus 1. So we get 2m minus 1 is equal to 0. If you take minus 1 to the right hand side, it will be plus 1. And to get the value of m, we should transfer now 2 to the right hand side to have 1 divided by 2. So we get the value of m as 1 by 2, which is given in option C. That's why option C is the correct alternative. So the value of m is 1 divided by 2. So this is how we can solve some examples based on the quadratic equations by using the concepts of the standard form of quadratic equation, or the roots of the quadratic equation, or the nature of the roots of the quadratic equation. I hope you understand this concept. Thanks for watching.